Today's lesson is on the basics of functions and their graphs. First, we'll start off with a few definitions. The definition of a relation is a set of ordered pairs. If I put a set of ordered pairs together and I say that they belong together, then that set of ordered pairs is a relation. Within that relation, we have two sets of groups. The set of all first elements in the ordered pair is called the domain, and the set of all second elements in the relation or in the ordered pair is called the range. The following is a relation. We have a set of students and we have their corresponding color of their shirt. So let's say April has a blue shirt, Bob has a gray shirt, Carlos is wearing a red shirt, Dion is also wearing a red shirt, and Ava is wearing a yellow shirt. This is a relation. We have a set of ordered pairs, and they belong together because we group them together. So we're going to go ahead and define two sets, A and B. Set A I'm going to define as the student, we'll say April for the first point, comma, blue, and so on and so forth. Bob, comma, gray, Carlos, comma, red, Dion, comma, red, and Ava, comma, yellow. Similarly, I'm going to create another set B, yet this time I'm going to create the set so that the ordered pairs are opposite. Blue, comma, April, gray, comma, Bob, red, comma, Carlos, red, comma, Dion, and yellow, comma, Ava. Within these two sets, we have a domain and a range. We said that the domain is the set of all first elements. So let's look at set A. The domain of set A is the list of all first elements: April, Bob, Carlos, Dion, and Ava. Whereas the range is the set of all second elements, so the range of our set A would be blue, gray, red. Notice red is both Carlos's shirt color and Dion's shirt color. Although I'm not going to write it twice, that would be just a little bit redundant. So write red only once, and then Ava's color is yellow, so yellow is in my range as well. Similarly, the domain of B is the set of all first elements in our set B, which is blue, gray, red, although I'm only writing it once, and yellow. The range is the set of all second elements, meaning our students April, Bob, Carlos, Dion, and Ava. So that summarizes what a relation is and a domain and a range. Although there is a special kind of relation that we really want to study today, and it's called a function. A function is a relation where each element in the domain corresponds to exactly one element in the range. Sometimes I think of this function as kind of like a little machine. And I have an input for my machine and I have an output. My input is my domain and my output is my range. So if I plug some value in my function, we'll say the input, I'm supposed to get the same output every single time. No matter what I put in for my input, I would expect the same thing to come out every time. If I put in April, I would expect to get out blue if I was talking about my set A. If I put in Bob, I would expect to get out gray, and so on and so forth. If I put April in again, I wouldn't expect any other outcome than what I had got the original time. If April was assigned to be blue, and this was a proper function, then when I plug in April again, I will surely get out blue. Otherwise, it wouldn't be a properly working function. You wouldn't expect to put something in a machine and two different things to pop out at different times. A properly functioning machine, whenever you plug an input in, you get the same output every single time. And we're going to come back to that in just a minute. Another way we can write sets is using diagrams, where we show the mapping or correspondence between the domain and the range. For set A, I'm going to let the circle on the left be the domain, and the circle on the right be the range. Within my domain, I have April, Bob, Carlos, Dion, and Ava. Within my range, I have blue, gray, red, and yellow. And the mapping, or the correspondence, is April has a blue shirt on, Bob has a gray shirt on, Carlos has a red shirt, but also Dion has a red shirt. So Carlos and Dion are both being mapped to red, whereas Ava has a yellow shirt on. Let's look at our B set. In my domain of my B set, I have blue, gray, red, and yellow. In my range, I have April, Bob, Carlos, Dion, and Ava. And then we will map our correspondence. Who is wearing a blue shirt? Well, that's April. Who's wearing the gray shirt? Bob is. And who's wearing the red shirt? Carlos and Dion are both wearing a red shirt, and the yellow shirt is worn by Ava. Again, this is my domain and my range. So is set A a relation? Well, certainly it is, because I have a set of ordered pairs. That's not a very interesting question. The more interesting question is relation A a function? Well, let's go back to the definition of a function. A function is a relation where each element in the domain, every input, corresponds to exactly one element in the range. If I plug in to my function machine April, I'll get out blue every single time. If I plug Bob into my function machine, I'll get out gray every time. I plug in Carlos to my function, I'll get red, and Dion, I also get red, although every value in my domain is only being mapped to one thing. Although Carlos and Dion are both sharing the same range value, this is a function because every element in the domain is being only mapped to one value in the range. Although the range can have as many overlaps as you want. The domain is the one that needs to be on its best behavior. Every element in the domain can only be mapped to one element in the range. So is this a function? Yes, this is a function. Relation A is a function. Let's look at relation B. Blue is being mapped to April. If I plug blue in my function machine, I'll get out April every single time. If I ask my little function machine, who's wearing the gray shirt? It'll tell me Bob. If I plug in red to my function, it may give me Carlos or it may give me Dion. In this case, I don't think this function machine is working real well. Your machine is only allowed to give you one value out, and it has to be the same value every single time. If I keep putting in red and I get out different values, this function machine is broken. In fact, it's not even a function. So this is no. B is not a function. The domain is the set that needs to be on its best behavior. This red is trying to be mapped to more than one in the range. That is not okay. The red is the one that's creating the problem here because the red in the domain is trying to map to more than one element in the range, and that is why B is a relation, although it is not a function. Functions can be expressed several ways. Today we're going to be studying functions as sets, functions as equations, and functions as graphs. Let's take a look at the three ways these might look. A function as a set might look like a list of ordered pairs. For example, 1, 2, 3, 4, 5, 6. That same function could also be written in a t-chart. 1 is being mapped to 2, 3 is being mapped to 4, 5 is being mapped to 6. We can either write x and y here, because often our domain we label as x, and often my range we label as y. Or the other way we can express functions as a set is using our domain and my range to show the mapping visually. I guess that should be a 6 if I'm using the same function. Functions can also be expressed as equations. For example, y equals x plus 1, or another example would be y equals 4x squared minus 2, and so on and so forth. Some equations are functions, some equations are not functions, and we'll be talking a little bit about how we're going to be changing the notation here. We're going to be using function notation, and we'll learn about that in just a few minutes. And then the third thing we're going to be looking about in this lesson is functions as graphs. So functions as graphs can look like a variety of graphs. We'll be studying a lot of these graphs in detail this semester. Just give you a few images, but we'll be studying a lot about functions as sets, equations, and graphs in this section.